In this video, I am going to present a project which is the TIC-TAC-TOE game implemented in a DEO-NANO FPGA board. For those who are not familiar, the TIC-TAC-TOE is a game played by two players, and whoever first draw three marks in aligned position will win, whether it is vertical, horizontal, or diagonal position. Unlike other projects, this is just a simple project just to help me enhance my skill in design and learn more about the FPGA board, Verilog coding, and some hardware implementation. This is the design of the project. First, I have the DEO-NANO development board. This will be used as the processing unit. This one, an array of TAC or mechanical switches. Since the DEO-NANO has no built-in switches unlike the DE2115, I created an input panel for the player input. The input panel is just simply comprised of TAC switches paired with pull-down resistors. The display for the output will be a computer monitor with a BGA port. So for this tic-tac-toe game, it will be a human versus a computer. Uh, the first move will be played by the human player, and after inputting his move, the DEO-NANO will respond a move. It's either a move to defend or for the win. Then after, it will wait for the response of the human player. If one of the player has drawn three marks in aligned position, the player is declared as winner. The three winning marks will be displayed in blinking manner indicating the winner and the game is over. If all the slots are already marked, the game will conclude as draw, and all the markings will be displayed in blinking manner. For the coding part, there are already existing Verilog code for the tic-tac-toe game, but it does not fit well for this project. But somehow it helped me to make my own Verilog code. The block diagram is this one, comprised of several modules. First is the clock convert module. This module simply creates a 2 Hz clock or 0.5 second pulse period from the 50 MHz clock of the DEO-NANO board. Next, I created the module get player move, which is used in storing the input of the user based on the input panel or switches. The module getComputerMove is used to generate a response based on the previous moves of the human player. It took me some time to create the code for this module since all the possible moves are needed to determine so that the computer will not be easy to defeat. Uh, but prior to the generation of the respond move of the computer, a module which is the comp move is connected to the get computer move. The comp move initially assess if what to respond for the play. Is it for defense or for the winning move? Another block is the winner detect module. This module continuously determines if there are three marks in aligned position. Next is the display module. This module compiles the computer input and the human player input to the intended position. This make the data to be easier to manage or determine which slot is vacant or not. The BGA controller module was based on my previous laboratory output. I just modified and inserted some codes so that it will fit in this project. The BGA controller generates the signal to be fed to the computer monitor through the BGA port. So this is the actual code for the game. So this is the main code, TIC-TAC-TOE module. This is the clock convert. This one is get computer move, then comp move, display module, get computer get player move, BGA controller, winner detect, and comp move. Uh, there are a lot of things to optimize here, but as you can see, there are no latches based on the RTL or synthesis of the Quartus tool. For the input panel, I use TAC switches as the trigger to input the move of the player. There are 9 switches for each position and 1 for the reset. This is the circuit diagram of the switches. The resistors are the pull-down resistors connected to the ground terminal. One end of the switch is connected to the GPIO of the DEO-NANO and the other end is connected to the 3.3 volt terminal. One of the challenges here is the switch bouncing effect, which is a non-ideal behavior of a mechanical switch. Every time I press the TAC switch, it generates multiple transitions before it gets stable. Initially, I ignored this switch behavior. However, it significantly affects the input and output process on the DEO-NANO board. There are methods to address to the bouncing effect. One is creating a simple debouncing circuit, and another is by software debouncing. I use the method for software debouncing so that I'll no longer add more passive components. The scheme is simply adding some clock edge based code or sequential block and generate a signal on the stable part of the signal on the TAC switch. The output is displayed in a computer monitor. This part is really fun and I was able to appreciate further the BGA controller. At the BGA port, I instead of splicing the whole BGA cord, I just select the pins assigned to the red, green, blue, V-Sync, H-Sync, and the ground. These pins are hooked up to the GPIO of the DEO-NANO board. So this is how I format the graphics on the display. The dimension is 800 by 600. I just pick the coordinates by dividing the areas where to display the game and the positions. So now I will try to play the game. So I upload the code to the DEO-NANO. So I click this one, then the computer will respond, then my move, then the computer, then this one, and So the computer created a straight line. So the computer wins. Then I'll reset. Then I click this one. Okay, this one. Then this is a draw. Then reset. Another game. Click this one. Then the respond this one. Okay. Then the computer wins. Another game. Click this one. Okay. This is draw. Okay. So that completed the project, and these are all my references. And shout out to Sir Jefferson Hora. Thank you for all the knowledge I've learned in doing this FPGA stuff. That's all. Thank you for watching.